tasto nella cartella, tasto di là nella cartella, tasto destro giorno, ok, line ricarico, poi non vai non c'è solo source, tanto la cartella è già
I don't know where, but there is a problem with this instruction here, which I comment, because I rewrote it and now it goes. So probably the parentheses, because I think there are some unnecessary ones. Anyway, now it works, okay? And it's your job to find it. Yeah?
Yeah, just to see.
Yes?
Although I create a function.
Use the argument. But the graph is fine.
There's no error.
Ah, there is no graph. Okay, yeah, there is an arrow. So let me see the code. Okay, you have to put a C here, basically. When you go here, I want C. Otherwise, should be a vector. We see how it works. Yes, perfect. Okay. These are basically all problems that come from not perfect, how to say, it means that you are not perfectly used to programming, so you have to make exercises, because what you're missing in all this problem, what you're missing is the capability to identify mistakes. And therefore, in programming, this is a kind of, everyone has his personal way of identifying mistakes. But what you should do basically in the code is to include instructions, add instructions that allow you to make a check. For instance, in R, you can use the instruction cat to plot some preliminary intermediate results. So basically, one thing that you can do is to identify the problem. In the first case, what I did is to modify the program so that it gives back not just the sum of squares, but the whole vector of observations. And therefore, I checked that there was no missing values there. And then I thought, okay, the problem is not missing value. What is the problem? And then in the second case, I rewrote the instruction, because sometimes when you make a mistake, the easiest way, once you identify where is the mistake, is to rewrite the instruction. Because otherwise, if you check, it's difficult to see the error. So you need exercise. If you want to improve programming, you need some exercise. And what you're missing is not your capability of writing down the program. I see that you're good in this. The problem, okay, let's say in this case the program I gave it to you, but I don't think your main problem is that. Your main problem, as any beginners, is the capability to identify the errors. Okay, let me move forward now. So basically what you see here is a comparison between observed red and simulated black data. Of course the comparison is not fine, and therefore let me just try to make, it's useful to make some more experiments. And let's try to increase the last two parameters, for instance. And let's see what happens. I just put 12 and 12, just, you know, to make an experiment. And it means if this is not fine, it means it gives an error because you have infinity, basically, in some of the computations. So the problem is not the last two, but let me see, because I think, so let's try to decrease them. It was 0.5, let me see, 0.01, 0.01. I'm just making some trials. And now let me go back. You see that now the situation is much better. I don't understand why there is a mistake in the scale. Let me see. I don't know. Anyway, no problem. But the situation is much better. But of course, what we have to find now is the correct combination. This was what I tried. Let me make, sorry, just if you pay attention just a second, let me make a change here in the program. Let me make a change here because you may notice that I found that the scale of the graph is not automatically adapted. So I tried to figure out why, and then I understood why. Because here, the limits for y are put at the max of Qt, not at the max of the considered part of Qt. So basically here I have to add, again, be careful of what you write, I and delta t. Be careful of what you write, okay? Now it should work. And let me try, let me go back in R. I source it, and then I try again 0.01 as parameter, and now it should work. Now it works, you see? Okay, so now the problem is that we have to identify the most correct parameter set in an automatic manner, because otherwise, you know, it becomes really time-consuming. And let me do like that. In order to start an automatic optimization procedure, we have the problem that it's quite slow, because you see that for one computation it takes about 3-4 seconds. The automatic calibration takes about 1,000 computation. We cannot wait for 1,000 seconds. So let me shorten the calibration period even more, okay? So let me change back in the code. Let me put sk equal to 4,000. And then let me go back. I have to source the program again, and then we can make our simulation. And let me check if everything is fine. Yes, you see that, first of all, it was much quicker. You see, it becomes much quicker, and it's automatically adapted, the graph, I mean. Okay, at this stage we can start with the automatic calibration. What's the problem?
It's not the same number.
Sorry, it's not the same number. It's much different or not? Because you know, it's a different operating system could give a different number, but not really much. What about the others? Do you find the same number?
Yes.
Do you do? The operating system is Windows. Your operating system, sorry. It's Windows.
Windows 7.
Okay.
I didn't put N another time.
Sorry?
In the script,
Ah.
I didn't write N.
And what happens there? And what about you? You get the same number or not?
No.
But did you put 4,000 in the
Yes, in SK.
SK? And did you upload again the code?
Mm-hmm.
Before you have to say, did you remember to say?
Oh, yes.
Adesso proprio ci dice.
Sì, sì, ho ricordato anche quella
Se non c'è scarica a casa ti posso
faccio la pagina. La così, no? Appunto, capito? Perché adesso ho toccato lo scritto.
No, non è che vuoi
Yeah, but probably it was my mistake, just one second. This one?
Altrimenti veniva questo valore.
Sì, poi era... Aspetta, ah sì, quello sì, sì. Poi mi tornava.
Okay, the graph seems to be correct. So, just a sec.
It's until 3,000 here. And
Let me see.
why?
Yeah, should be 4,000.
I think
Let me see. Because I think you didn't change here and delta t, which should be 8760. Yeah, but still it's not correct.
no.
Still it's not correct.
No, maybe.
Yeah, but the result is not correct. It's 5 million, so there is something wrong.
Voglio rivedere il momento in cui vi chiede a voi torna a paesi e noi ci insultiamo
L'hai fatto da prova da destra?
Okay, I made a mistake. Let me
No,
see.
dall'altra parte.
I think the stage is correct as you did before, so basically,
come se stanno in
let me see.
I layout sono tutti accesi?
che fanno?
No, this
Fai
one should
zoom out.
be changed. Okay, let me see.
Ma lo stesso anche questa scritta.
Okay, so let me do this.
Non è che gli messi in qualche blocco?
Because I think the only mistake was here in this standard team, and then the remaining part was fine. Because then I introduced another program, so now should work. Let's see. Okay, good. So everybody's okay? Okay. Perfect. So let's move forward. Now we need the optimization routine. So let's install it. I think we already discussed on this problem, on this solution. So install that packages, commas, DA optim. And then you should get a window that asks you to select a mirror. Just select what you, doesn't matter, okay? The only thing that matters is that you have to have the network. Let's hope that you get it. And yeah, I got it. By the way, you know, it's, I think that politely you should voice your opinion that the University of Bologna should have a reliable network. I'm saying this every time, but you know, students are more important. So if you get an opportunity, just complaints or things like that, just in the questionnaires, put this. It's amazing. You know, I understand we have old buildings, etc., but
He's asking me to create a new library.
yeah, just answer yes.
Yes. And then select the ground.
But if in the other exercise we have already installed it.
Yeah, yeah, if you already did it, you just need my next instruction, okay? Everybody got it? Okay, now you have to, the following one is library, DE optim. I already explained to you why you needed to type the second instruction. And the reason is that when you start the program, every time you have to write library DE optim. And the reason is that you don't want to upload all the packages that you installed, otherwise it becomes too slow. There is a way to tell R by default to upload the library each time. There is the way. I don't remember how to do that, and let's not lose time now to solve this problem. I just wanted to let you know. Okay, there is a way to tell it automatically. because there is a way to tell R when it starts to automatically execute a series of instructions. This is quite simple. You just need to create a file and put it in the R directory. But anyway, again, let's not lose time on that. Now, we can start the optim, okay? And let's give the result to a dummy variable. So the optim imod. Lower equal C, lower parameter vector, lower value for the parameters. So let me put here 50, 0, 0, 0, 0. Upper equals C, 800, 1, 0.5, 0.5. Good. Let's see what happens. And let me go to the graph. You see the several attempts here. So I can leave it running while you
Sorry, I can upload the library. When you have a library, the optim, there is no package called the optim.
But did you install it?
Install it. I have a lot of warnings, but
A lot of warnings. Try to install it again. Install packages again. Is it running yours? Yours is running, correct? It's running? Okay.
no, I installed it back, but
Yeah. Let me see. No, it's not available, so ancora install packages, non c'era dentro.
Perché scusi?
Non va proprio
a me non
non c'è modo, nel senso, però adesso ormai è finito. Okay, now let me say a couple of things, because you see it's very nice, it's working for us. So a couple of things, it takes a lot of time, so we don't have time now to wait for the program to finish. And one way to speed up the process is to remove the plotting of the results. This is completely useless. It's just useful for us because you see that it's going. And as you leave, if you leave it running, then you would see that it converges quite slowly, but it converges because still you see that at this stage you have some simulation that is very wrong. If you wait for a while, then you would see that it converges. But in this case, this is, of course, it takes time, we can't wait. Now let me just mention what you should do in order to check if everything is fine. When it terminates, first of all, a couple of remarks. When it terminates, you get a result from the optimization, which we assign to a variable, and the variable that you get is a list, meaning that you already know what is a list. There are several names, subnames for the variable PR1. You will get many subnames, and one of these is the best parameter set. And if you want to get the best simulation at that stage, you have to rerun iMode with the best parameter set. So it doesn't automatically give you the routine, the best simulation, the best graph. You have to rerun it again. Okay? It just gives to you the parameters. Now, once that you have the parameters, this is the calibration that you finished. Then you should perform also the validation. What is validation? You should try to run iMode in the first 4,000 of data. Maybe not the first 4,000 because the first 2,000 were not really good. But you should run iMode, let's say, in a piece of data that you didn't use in calibration in order to check if the simulation is correct. This is a kind of check of how the model performs in a real-world application, out of sample. Out of sample means not using the data that you used to calibrate the model. Because of course, the data that you used for calibration, the model is already trained to them. So it's adapted to them. But you are not sure that the model performs well in a real-world application. Okay, we are not doing this because you know, we could do that if you want next week, once that we have the best parameter set. So you may go home and let the computer finish. I think it may take 1 hour to finish this, not the 10 hours. You could leave it working, and then when you have the parameters, just try to perform the validation. And if you can't, we can try together next week. If you give to me the best parameter set, it's very easy, by the way. You have to run iMode with different by using different pieces of data. Okay, first. Second, you may want at a certain point, you may get bored, meaning that, you know, the program is very slow. I said 1 hour, but who knows, maybe after 24 hours it's still running. Then, if you get trapped in a similar situation, it could be, you know, a good idea to ask the function iMode to plot on the screen the parameters at each step. In this case, we are asking the function to plot the data. But you may ask the function, you could insert in the function an instruction that plots on the screen the parameter values. Why this is useful? Because at each step you see the parameters. So once that you get close to convergence and you see that every simulation is fine, the program may keep running because maybe that he's looking for tiny details, and you may say, okay, I'm already satisfied, and then you stop the program with a Control-C. You will see now with a Control-C I stop it, but I don't get any output now. Instead, if you get the parameters plotted on the screen at each step, then you get at least the parameters you can cut and paste from the screen. Okay? And these are tricks that you have to learn because, as I said, what you are missing in your programming experience is just the tricks. Okay? And of course, these are important. Okay, good. So, let me move forward now. Let me stop here with this. And in order to stop, as I said, I go back to R. But you see that after some iterations, you get, I forgot to tell you this. After some iteration, you get the best parameter set that he got. And let me say that it's already at iteration 6. It wouldn't take much to get to convergence. And you see here, there is what you get, there is the best value, 27,000, and then the best parameters, 155, 155, 0.37, 0.6, 0.02, 0.15. These are the best ones. Still, you know, they are much variable because if you compare with the best ones that we got at the previous steps, they still vary a lot. And let me see if, yeah, we are still far from convergence. You see, there is still a lot of variability. So these parameters still are not good. Okay, let me stop it. Control-C. Let me see if I am successful. Yes. But as you see, I don't get any output, so it's not really, how to say, it's not really the best. Or you may try with ESC. Okay, good. Now, let me move forward to the next exercise, which is, you know, should be simpler, but anyway, I don't want to anticipate anything. And the exercise, let me open my web page. Or maybe that instead of opening the web page, let's see, let me get it now, from the PC. I don't have it here, so. Yes, I don't have it here. I have to. Try to make a check if I can get connected. You don't need to really get access. It's just me because I need the text. Okay, I was successful. So, here is the text, just 1 second, let me open it. Here it is. Let's. It doesn't matter if you don't have it because it's just descriptive. Okay. First of all, there is a spelling here, spelling error, but no problem. Okay. Application of pairwise comparison to estimate the design flow of an hydropower plant. Indeed, we are not. We are just performing here a first step. We are not getting to the design flow. Basically, what the problem says, in a river cross-section hydropower plant need to be designed, the criteria to be met to reach the optimal design are economical benefit, impact on the ecosystem, impact on the landscape, impact on the touristic appeal of the river. Determine the optimal weights to assign to the above criteria in order to identify the optimal design. So we just need to identify the weight, correct? Okay, good. And let's do that. And in the exercise in the website, you find an R code, which is very short. So even if you don't have it now, don't worry, because you don't need it. And then an Excel file. So let's start in this way. Let me open the Excel file, but let's start from scratch. So basically here there is a matrix of indicators. Let's delete it and let's start from scratch. So let's draw our pairwise comparison matrix. So let's start from the beginning. You may remember that the pairwise comparison matrix has as labels of the rows and columns the 4 indicators. And you may remember that it is a diagonal matrix. What we have to write here is the importance of each indicator with respect to the other. So what is the importance of indicator 1 with respect to indicator 1? 1, okay? And then what is the importance of the second indicator with respect to the second is 1. And so let's put 1s in the diagonal. Is this clear to you? Okay. And now we have to write our pairwise comparison matrix for the other indicators. And let's do it together. Let's try to reach an agreement among us. Let's see if this is possible. Let's emulate a real-world situation. So first of all, we need to remember what the indicators are. Now we have to compare indicator 1 with indicator 2. Let's go back. What do they mean? Indicator 1 is economical benefit. Indicator 2 is impact on the ecosystem. So you may remember that if I put here a value that is greater than 1, it means that the economical benefit, I1, is more important than the impact on the ecosystem, and the scale is from 1 to 9. If I instead put a value lower than 1, from 1 to 1/9, it means that the impact on the ecosystem is more important. So what should we put here, in your opinion? There is no right answer, it's just your perception. It's more important the ecosystem or the economical benefit? And you should reply, it depends of course on the context, on etc. and etc. And let's put, because you know we don't want to put much weight on the economical benefit.